Here we are looking for doing kind of our first applications with antiderivatives. So just finding a specific function. So an initial value problem requires you to not just take the integral or the antiderivative of a function. It also requires you to find the specific constant c on that original function. So we've been ending all of our answers with a plus c, and now we're going to figure out what that c value would be for a specific function. So we are given a function's derivative and a point on that function, and our job is to figure out what was the original function. So these are going to require 3 steps. The first step to figure out what function has that f prime for its derivative and has the point 1,5 on it is going to be taking the antiderivative. So we want to go from f prime of x back to f of x, so we're working that backwards direction. We're taking an antiderivative. If we wanted to go from f to f prime, that would be the derivative, and so that's how I know going from f prime to f would be the antiderivative. So in this case, f of x is going to be the antiderivative of 3x plus 2. We're going to do this with respect to x, so we have that dx on there. So f of x, I'm going to take the antiderivative, which means I'm going to keep the constant multiple 3, add 1 to my power, 1 plus 1 is 2, so we're going to have 3 over 2, x the 2. Antiderivative of a constant is that constant times x plus c. There's our first step, taking a regular antiderivative. And now our second step is to figure out, well, what would c have to equal to have the point f of 1 equals 5? So to find c, which is our second step, we're going to plug in the point. We're given f of 1 has to equal 5. So we're going to plug in 1 to that function that we just found. We said that f of x has to be 3/2 times x, which is 1 squared, plus 2 times 1, plus c has to equal 5. And that's just because that was the point given to me. That when we plug in 1, we have to get 5 out. So I can grab my calculator and multiply this out. I have 1 squared to do first, which is just 1. So 1 times 3/2 is going to stay 3/2. Plus 2 times 1 is 2. Plus c equals 5. And I still need to try to get c by itself. So one thing I could do is combine the whole numbers first. So I could subtract 2. So I have 3/2 plus c equals 5 minus 2 is 3. And then I do have to eventually subtract that fraction over. So 3 is the same thing as 6/2 minus 3/2 is just going to give me 3/2. And then my third and final step is to write the overall function. So I'm basically combining what we found in those first 2 steps. So we know the original function must have been this f of x, which is 3/2 x squared plus 2x plus what we just found for c, which was 3/2. So there's the function that has the derivative f prime is the 3x plus 2 and has the point 1,5 on it. Now, if we're not sure of our answers, what we would do is we would take the derivative to check. So we would take the derivative of what we just found, derivative of 3/2 x squared, bring down that power. 3/2 times 2 is going to be 3, x the first. So the first part of the derivative is going to be 3x, which is perfect. Derivative of 2x is 2. So it looks like we got that derivative right because the derivative of 3/2 at the end is a constant, so it's 0. So it definitely has the derivative. So the other part would be plugging in 1 into the function we found and making sure that we do get 5 out. So you can definitely check your answers for these by taking the derivative, get back to that f prime, and then also plugging in 1 and making sure you get 5 out for the y value.